Hello, IB buddies. Super stoked you are here. I know chemistry is tough, but no, I'm here to break the myth that IBDP chemistry is tough. And especially talking about organic, you feel like it's a beast. But guess what? We're gonna tackle it together. And I'll show you it's way more fun than what you are thinking of. We'll kick off with a very chill and super approachable topic, which is isomers. We'll break it down simple. We'll practice the past questions of that particular topic. And I promise one thing, just 20 to 25 minutes a day, and you will be crushing it for sure. So we'll start with the most recurring topics first. So the very first is Isomers, and then we'll go one by one to the next videos. So let's start with Isomers. So what do you think of Isomers? If question comes, define Isomers. What are we going to write down? So isomerism is for compounds that have same molecular formula but different structure, right? They have the same molecular formula, but they have different structures. That a simple isomerism is. Now, this isomerism is further divided into two broad categories. The very first category is a structural isomers, and the one is stereoisomers. Right? The structure is further divided into three parts. You have chain isomerism, position isomerism, and functional group isomerism. This stereo is divided into two parts: geometrical isomerism and optical isomerism. We'll discuss this. Geometrical is further divided for two parts: cis, trans, ENC format. So this is a broader classification of isomers, right? Now let's first start discussing about structural isomers. Now, as a word itself says, structure varies. The compounds whose molecular formula is correct. Now, when I say molecular formula, it means writing down something in a condensed form like C4H10. This is the molecular formula, right? One you call as displayed formula. Displayed formula is the one in which you show all the bonds. So this will be my displayed formula for butane, right? One is skeletal formula. Skeletal is just to use a line and no carbon and hydrogen is being shown. So I have 4 carbon, each dot represents 1 carbon. So 4 carbon, 1, 2, 3, 4. That's it. It's predefined that something which is not shown. Apart from that, it's hydrogen. And then you have one structural formula. Structural formula is nothing but you write down as it is. What is this compound actually showing? So it is having CH3, then you have CH2, then over here you have CH2, and this is CH3. So this is the structural formula. please note down one thing. Many a times question asks you to make molecular formula, display it, skeletal or structural. Please stick to that. Question asks you structural, you are making molecular formula, you might not get marks on it, right? So yeah, come back to the structural formula. So when you say a structural isomers, that means this is different, right? Your compounds are not looking like this. The molecular formula is still the same. It is C4H10 only. Okay, what's the name for C4H10? 4 carbon. 4 means bute. All single bonds. Single bonds means ane. So the name of the compound becomes butane. Perfect. That means the molecular formula will retain of butane. It will have 4 carbon with 10 hydrogens, but the structure will not remain the same, right? So in that, let's talk about the very first isomers, which is chain isomer. So let's do it for butane only. So you have first CH3, CH2, CH2, CH3. This is the very first possible isomer. Now, second, what you can do is, I will remove one carbon from here and I will attach it in the chain, in the remaining chain. Now, one point to keep in mind over here, when you will remove it from here and you will attach it from anywhere, you will not do it at the first, you will not do it at the third, last one. Reason behind that. If you say, okay, I have attached like this and fourth one I am attaching with this over here, or I am attaching it over here, it is still the 4 carbon in one single chain. Now, I'm still not converting 1, 2, 3 and 4, or I can call 1, 2, 3 and 4, right? My chain is still the same. So when I say chain isomers, that means my parent chain has to be different. So if I cannot attach on the first, I cannot attach on the last. What is the option left with me? I can only attach it in the beginning, in the middle, which is CH3, CH, CH2. Now this is the compound. Now you keep in mind one thing. You are saying you are attaching over here. What? This CH3. If you will attach the CH3 over here, can the CH will have CH2? No. Why? Because each carbon can have just 4 valencies. It is already having 1, 2, 3, and fourth is this hydrogen. So where is this hydrogen going? It will go to this next carbon. It will be this, right? So now if you number the compound, you can number it from the starting or you can number it from the back. 1, 2, 3. Or I can number it like 1, 2, 3. No difference. My name will still remain the same. What? At second carbon, I am having a branch. This is my parent chain now. This becomes a branch. What is this? Methyl. One is meth. And with one less hydrogen of alkane becomes ide. So 2 methyl. Right? Then 3 carbon in a chain. 3 is prop. All single bond A. So 2-methyl propane and butane. These are my 2 possible chain isomers. Clear? Any questions? Moving ahead to the next isomerism, which is position isomers. Now the word itself saying what? Position. Position of what? Now you can say position to yahan bhi change ho rahi thi. Over here also we are changing the position. But chain will change because of that position, right? Over here, when you change the position, what position could be changed? It could be the change of double bond or triple bond, or it could be functional groups. That means in this case, your parent chain is the same. Only the double bond, triple bond position is changing, or the functional group position is changing, right? Example. Let's take this is a number. Let's number it first and name it. So, okay, should I start from the beginning or from the end? I'll start from the beginning. Why? Because my halogen is attached in the beginning. So this halogen is chlorine, and you call this chlorine as chloro. All halogens are named as halo. So chloro, bromo, fluoro. So it becomes 2-chloro. Why 2-chloro? Because it is attached in the second carbon. How many carbons now? 4. 4 means bute. So 4-2-chloro butane. Yes or no? Any questions, any doubts? Now, I am saying I am changing this position of chlorine to this position, to carbon number 3. Now, should I write down 3-chlorobutane? No. Why will I not write down 3-chlorobutane? That you will tell me in the chat box. I'm making the next isomer of it. So I will attach it either at the beginning or at the end. Only one place possible, right? CH3, CH2, 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 Cl. So when I place it over here, I will start numbering from here, from the back. 1, 2, 3, 4. So it becomes 1-chlorobutane. Yes or no? So what I have done, I have changed the position of the halogen. That is a functional group, right? Let's see one example of a double bond or a triple bond as well. So I will number it from here. 1, 2, 3, 4, 5. 5 means pent. So I will name it as pent 1-ene, or I can simply write down as E. If you write down 1-ene, that is also fine. Right? Now I can change this double bond to this position, or I can put this at third position also. Right? So I can make it right. So yeah, I will number it from here. 1, 2, 3, 4, 5. So now it is coming the double bond at second carbon. So it will be pent 2-ene. Right? Now, if I place it over here, should I call it 1, 2, 3, 4, 5? Pent 3-ene? Should I call it? Reason. My numbering will be from Beckett. So again, it is at the second carbon. So again, there are only 2 isomers possible, pent-ene and pent-2-ene. I hope position isomers is also clear. Moving to the next one, which is the functional group isomerism. Now, what does the word say? Functional group. How a functional group will change? Position is changing, chain is changing, doable. Functional group is itself changing. How is that possible? So that is possible. Now, when you change a functional group, you need to keep in mind one thing. What is that? Let's say we have an alcohol group. Now, alcohol is what? You have OH group attached to one of the carbon. Now, in this, the oxygen is attached with a single bond to carbon. So it can interchange to any other functional group which has just one oxygen, plus that oxygen is single bonded attached. Like what? Ether. Yeah. So these two are interchangeable. So what is the key thing that we need to keep in mind over here is number of oxygen you need to check and bond with carbon. Similarly, if you have like aldehyde, aldehyde is what? CHO, right? Now over here, what is happening? You have a carbon attached with double bond oxygen. One oxygen, but double bonded attached. So what could be the case? Just one oxygen, double bond attaches ketone, right? So that means these two functional groups are exchangeable. Another, carboxylic acid. What is that? C double bond O, OH, right? Two oxygen, out of which one is double bond attached. Two oxygen, one double bond attached. What could be the change? Yeah. So these are interchangeable functional groups. Pen down, note it down, put it into your mind. Just make a note of it and keep it into your pocket and flow it into your heart like anything. So now let's see an example of each one of them one by one. Let's say you have butanol. So butanol will have the formula CH3, CH2, CH2, CH2OH. This is butanol. If I will make ether out of it, so I have to put the oxygen between two carbons, right? You can put it anywhere. So this is butanol. So what will be the name of the compound? This is one end. This is another end. So you name it this as single carbon methoxy propane. Right? Perfect. For today, let's wrap up the session over here only. I hope that after this, you will be feeling a bit more confident when it comes about structural isomers. If you have any questions, any queries, please do drop it in the comment box. I will be more than happy to solve your questions, your queries. If you have any other thing which is bothering you, which is the concept which you like that we should come up first, just let me give a comment in the comment box, and I will try to come up with that particular thing as soon as possible. In the next video, we'll start out with the stereoisomers. Till then, take care and have a good day. Do hit that subscribe button, and let's meet in the next video. Bye bye. Take care.